Okay, this is exercise set 5.4, question 2. So this is on page 203 of the text. I wanted to do some of these just to give you a uh, maybe a better sense of how they work. So this one exercises biconditional rules, but also you'll see some of the stuff from conditional introduction that came in section 5.3. Okay, so I'm starting with number 1. I wrote out the problems. I don't know if I'll get through all these, but we'll give it a go. Okay, so we've got one premise in this one. Trying to underline it. And our conclusion is a conjunction of two conditionals. So whenever we want to get a conditional, we can use conditional introduction. So let's start with the first conditional, I conditional B. So if we want to use conditional introduction to get that, we start by indenting and we assume the antecedent of the conditional we're trying to derive, which is I. And then we write want B because we want to get the consequent of this conditional, which is B. So that line is just that. You don't need any more justification or anything like that. Now you have to keep indenting until you get the conditional. Okay, so now with I we can do a conditional elimination to get B and J. So that's justified by conditional elimination of 1 and 2. Remember, conditional elimination takes two inputs. One is a conditional, which we have on line 1. The other is the antecedent of that conditional, which we have on line 2. That's why we write 1, 2. And the output we get is the consequent of that conditional, which is B and J. Next step, we want to get B by itself. So we can get B by itself, and we can, for that rule, we can use conjunction elimination of 3. Anytime you have a conjunction, the conjunction elimination rule says you can have either conjunct by itself. And again, the reason for that is because if a conjunction is true, that means both conjuncts have to be true, so that means B must be true. So now we assumed I and we got B, so this we're done with this subderivation. So we move back to the original scope line. In other words, we're done indenting here, and we write I conditional B, and we justify that by conditional introduction of 2 through 4. Again, the hyphen is important here because it's this whole subderivation that proves the conditional. So it's not 2 comma 4, it's 2 hyphen 4. And again, it's the whole indented part. So our assumption was on line 2. The thing we wanted we got on line 4, so line 2 through 4. But of course we're not done. That's not our conclusion. Now we need to get this other conditional, I conditional J. So we do the same thing over again. We indent, we assume I, we want J. And again, that line needs no justification. It's an assumption that we're making. Okay, now one important thing to remember is if you're doing multiple conditional introductions, once you close one, like we closed this first one on line 5, all of this stuff in here is out of bounds. We can't use any of these lines because they were all based on this assumption that we made, I, and we don't know if I is true or not. So basically, we've proven I conditional B, so we have that, and we have our original premise up here, but none of this stuff can be used anymore. Okay, but we can, like I said, still use this, so we can do the same step and get B and J by conditional elimination of 1 and 6 this time. There's the conditional, there's the antecedent, that gives us the consequent. And again, we can do the same thing again, except getting J this time by conjunction elimination of 7. And that now gives us the conditional I, then J. And again, that's conditional introduction. Oops. Conditional introduction, and our assumption was on line 6, and we finished on line 8, so 6 hyphen 8. Okay, so now we have our two conditionals. We just need to do one more step, which is to put them together. I conditional B and I conditional J. That's conjunction introduction. We're introducing the conjunction. We got one conjunct from line 5 and the other from line 9, so 5, 9. And we're done. So that's one where you have to do multiple conditional introduction. Okay, next one, number 3, we've got two premises, and this is our conclusion over here. So it's a conditional. The antecedent is a conjunction, and the consequent is a conjunction. So whenever we are trying to derive a conditional, we can use conditional introduction. When we do that, we indent, and then we assume our antecedent, and we want the consequent. So we assume P and R, that's the antecedent. We want Q and S, that's the consequent. Okay, so now we're going to get P by itself by conjunction elimination of 3. And we'll get R by itself by the same step. Okay, so why do we want to get P and R by themselves? Because P and R are the antecedents of these two conditionals. So if we have P by itself, we can do a conditional elimination here, and if we have R by itself, we can do conditional elimination here. So that's what we'll go ahead and do. So we get Q by conditional elimination 1 and 4. 1 is a conditional, the antecedent's P. Line 4, there's the antecedent P. So with 1 and 4, we can get the output, which is Q. We can do another conditional elimination to get S. This time 2 and 5. Right? Line 2 is a conditional with the antecedent R. Line 5 is R. So conditional plus antecedent gives us consequent. Now remember what we want. We want Q and S. So now we have Q by itself and S by itself. So we just need to introduce the conjunction Q and S. So that's introduction 6, 7. So 6 is line Q, 7 is line S. So we put those two together by the conjunction introduction rule. So now that's what we wanted, right? So the subderivation part is done. The indentation part is done. We come back to the original, and we've just proven if P and R is true, then Q and S follows. That's by conditional introduction 3 through 8. 3 was our assumption. 8 was the line where we got what we wanted. So 3 through 8 is our subderivation. That's what justifies the conditional. Okay, now 5 is a biconditional. The conclusion is a biconditional. So how do we get that? All right. So the thing to remember about a biconditional, and if you think about the biconditional introduction rule, the biconditional introduction rule says that if you have two conditionals, namely K and J, conditional A and B, and you also have the conditional A and B, conditional K and J, right? These two conditionals allows you, by the biconditional introduction rule, to get this biconditional. And notice what they are. The one has this is the antecedent and this is the consequent, and then the other one is just reversed. The consequent here is now the antecedent here, the antecedent here is now the consequent here. So we need to derive these two conditionals, and then we can put them together with the biconditional introduction rule to get our conclusion. All right. So we'll derive this conditional first. So there we assume K and J, and we want A and B. I'll move those out there. I want to keep them up there so we remember what we're trying to get. Okay, so now we get k by itself by conjunction elimination of 3, and we get j by itself by the same step, conjunction elimination of 3. Why do we want to get those by themselves? Because now we can do biconditional elimination, right? Biconditional elimination is kind of similar to conditional elimination. If you get one piece, you can get rid of the other piece. So with k, we can get b by the biconditional elimination of 2, 4. So 2 is a biconditional, k is one of the sides, so we get the other side. Similarly, then we can get a by the biconditional elimination rule of 1, 5. It doesn't matter what order you do those in. Okay, so we want to get a and b, so now we just put those together with the conjunction introduction rule, 6 and 7, and that finishes our first subderivation, right? So now we got k and j conditional a and b, and that's by conditional introduction of 3 through 8. Okay, and then we're just going to do the same exact thing to get this conditional. We're going to indent, we're going to assume a and b want k and j. We're going to do conjunction elimination of 10 to get both a and b by themselves. Then we'll do the same thing. Now remember, biconditional elimination, you can go from left to right or right to left. That's the difference between biconditional elimination and conditional elimination. So here, if we have a, we can get j. Right? So we can get j by 1, 11 by conditional elimination of 1, 11. And remember what I was saying earlier, like this, all this stuff is off limits once we close that subderivation, so we have to do all this stuff over again. So we got j, we can get k, also by biconditional elimination of 2 and 12. We put those together, k and j, by conjunction introduction, 13 and 14, and that finishes our second. Sorry, we go back to the original scope. We got a and b, conditional k and j, by conditional introduction of 10 through 15. That's where we started our indent. That's where we got what we wanted. Okay, last step then is the biconditional introduction rule. So we get k and j, biconditional, a and b, and that's biconditional introduction of 9 and 16. Right, so the biconditional introduction says if you have this conditional and then the reverse conditional, you can introduce the biconditional. Right? So again, we did multiple conditional proofs or conditional introduction, and we got one part of our solution here, we got the other part of our solution here, and so the last step was to put them together. Okay, these can only be 15 minutes long because of the software I'm using, the free version. So I'm going to stop there, and I'll post 7 and 9 in a separate video.